and I may have to frequently scroll to look at the other things that we need to do. So first thing is domain. This is a polynomial. My domain is all real numbers or minus infinity to infinity. Problem number 2 says find the intercepts. So let's go ahead and say when is x 0, then f of 0 is 0. So looks like we have a 0, 0 intercept. And let's see what other ones we can find, if possible. So let y equal 0. So we've got 3, I'm going to factor out an x squared out of this whole thing. So this is x squared, 3x squared plus 4x minus 12. Actually, I should take out a 3 as well. So let's, oh wait, I can't do that, sorry. Alright, so the x squared is going to give us 0 with a multiplicity 2. Just means that it's 2 of the zeros out of the 4 that we have to find. So we've got 2 more in here. So we've got to solve 0 equals 3x squared plus 4x minus 12. Two numbers that multiply to negative 36 and add to 4. Can you guys think of any numbers that'll do that for us? So I don't think there is any set. So it looks like we're going to have to use the quadratic formula. Right, everybody's favorite. So x equals minus 4 plus or minus the square root of 16 minus 4 times 3 times negative 12 all over 2 times 3. This is going to be negative 4 plus or minus 4 square root of 10 all over 6, or negative 2 plus or minus 2 root 10 over 3. And let's just get a decimal approximation of those. So the plus term looks like about 1.44 to 2 decimal places. So we've got x equals 0. and x equals 1.44, and the other one is approximately negative 2.77. So I need the space, so I'm going to go ahead and get rid of the quadratic formula. So I go through the origin, and then I also go through these two x values. And this is when y is 0, so those are x intercepts, right? The third part says determine any symmetry. So to do that, I need to find f of negative x. So if I plug negative x into each one of these values for x, what happens? Well, any of the ones that are to a even power are going to become positive. And the one that's to the odd power stays negative. So it does not appear that this thing is even, because this does not equal the original. So not even. Then we need to see what is negative f of x, and is it equal to f of negative x? Well, that's going to change the sign of everything, and therefore that is not equal to f of negative x. So that tells us it's not odd either. So there is no symmetry here. So far we've got the domain, we've got where we touch the y-axis, where we touch the x-axis, and that there's no symmetry. All right. Fourth thing says to do what? I think that's the asymptotes. So yeah, we need to find the, if this thing was a rational function, we would find where it's undefined. This guy is from negative infinity to infinity, so there is no undefined portion. So we just need to find if there are any horizontal asymptotes. We do that by taking the limit of the entire function as x approaches infinity. Well, if we do that, that's pretty straightforward. This thing's going to be some kind of infinite value, so there's no horizontal asymptote. So no asymptotes at all, right? No vertical, no horizontal. Next part says, okay, now start using the first and second derivative tests. All right, fantastic. So first derivative, not too bad. Let's do that. So this is going to be 12x cubed plus 12x squared minus 24x. I'm going to factor out a 12x out of all of that. The whole point of taking this is to set it to 0. So once again, I get x is 0. And then I need to solve this. Is there a way to factor that? I think so. Let's see. We need two numbers that factor that multiply to -2 and add up to +1. So that would be +2 and -1. If we set those to 0, we get x equals -2 and x equals +1. These are our critical values. That allows us to break up the number line. And we have to choose test values. So out here I'm going to use 2. In between I'm going to use 1/2. Over here -1. And out here -3. So if you liked it, let's do the chart. Got x, -3, -1, 1/2, and 2 that I got to plug in. And the parts of the derivative are 12x. Then I've got the factors of x plus 2 times x minus 1, and then finally the product. I see that that's a little hard to read there. It's just these two factors in there. So if I plug a negative number into 12 times a number, that's going to be negative. And if I plug a positive, I get positive. Now, -3 plus 2, that's a negative number. -3 minus another 1, that's also negative. So negative times negative is positive. Plug in a -1. -1 plus 2, that's positive. -1 minus 1, negative. So that's overall negative. And then plug in a 1/2, so you get positive and negative. And then plug in 2, you get positive, positive. And then write down the products. So negative, positive, negative, positive. So this is increasing from -2 to 0 and 1 to infinity, and it is decreasing from -infinity to -2 and 0 to 1. The other thing that we can get from the first derivative test is where there's a change in sign. Those are local max and mins. So from minus to positive, that's a local min. So local max, I've got from when a positive goes to a negative. So that occurs at x equals 0. And then we've got local mins at x equal -2 and +1. So as you can see, we're getting a lot of information here. We've still got to do the second derivative test. So I guess I'll come down here. So 6 is the second derivative test. Here's my first derivative. So I need to take the derivative of that. Okay. So again, I should be able to take out a 12. And again, I'm setting this to 0, so I need to try and factor this again. I would need two numbers that multiply to -6 and add to 2. I don't believe that's going to work. Is there any way to know a global min or max? I think you mean an absolute max or min. And you really can only have absolutes if your domain's restricted. Or if I can plug any number into this thing, it's going to typically increase or decrease on one side and go on forever, so no. So let's see. Looks like we're going to have to quadratic formula this guy one more time. So just let me do that real quick. So looks like -1 plus or minus √7 all over 3. So yet another ugly number. And those are approximately let's just say 5.5. That's for the plus. And then the negative is approximately -1.22. Okay, so again, we would break up our intervals depending on these numbers. So yet another number line. So out here I could do -2, in here I could do -1, and out here, actually I could do 0 here, even easier. Out here I'll choose 1. So -2, if I plug that in here, all comes out to 6, so that's positive. Positive there. If I plug in 0, 0, 0, we get a negative. And if I plug in 1, I get 3 plus 2 minus 2. Looks like it's positive again. Whew, okay, so concave up. So this is from minus infinity to minus 1.22, and from 0.55 to infinity, and then finally concave down between those 2 points. Whew, okay. So quickly, let's just recap everything we just did, because I know that's a lot. Started with the domain. We then found the intercepts by plugging in x equals 0, and we got the 0, 0, the origin. And then I plugged in y is 0 and solved for x, and got these 2 points. Next step was to figure out if there was any symmetry. Turns out there was none. There are also no asymptotes. Then we took the first derivative, set that to 0, found our critical values, found our increasing and decreasing points, and our local maxes and mins. And then we took the second derivative, set that to 0, found our inflection points, and then determined where it's concave up and concave down. Now it's our job to use all this information to figure out what this thing looks like. So it's an x to the 4th, which means in general we'd expect it to look something like this. But that is symmetric, and we've been told that this is not symmetric. So one of these sides is going to be a little longer than the other. So let me come over here where I have enough space, see if I can't figure this out. So we know we've got to go through the origin, right? So we've got to touch here. We've also got to cross at, I'm just trying to get a approximate scale here. We've got to cross at 1.44, so maybe there, and then negative 2.77, so somewhere around there. Then we know that we are increasing, so I'm going to put a dotted line here. So we're increasing from -2 to 0. So it's got to be increasing in this area. So from here to here. We also know it's got to be increasing from 1 on. So if it's increasing in this region and in this region, it's got to be decreasing here, and it's got to be decreasing here. And then we've got a local max at 0. So it's got to be a max here. And I'll go ahead and, as soon as I get done writing this all out and drawing it, I will bring the camera over so you can see it a little better. So I know I've got to have a max there. I've got to have a min at -2 and 1. So here's -2. So I got to have a min there, and I've got to have a min here. And concave up from -infinity to -1.22. So it's got to be up over that region. And also from somewhere in here on. And then everything in between has to be down. Alright, so concave up means it's got to look something like this. It's got to be decreasing, so I've got to come down, and I've got to go through that point. My lowest point has to occur on my dotted line there, because that's a min. So I know over here I've got to be doing this kind of behavior. Right, and that's my minimum there. Then it says I've got to start increasing, but I'm still concave up until about here. Then I have to turn to concave down, and I have to have a maximum at 0. Then I've got to decrease from here on. I've got to be concave down for half of it approximately, and then start to be concave up. And then I've got to go through that point, so it's like something like that, I think. Now, if my scale's off, I'm going to probably get the two sides backwards. Let me just look at the actual plot. And I have no problem with you then plugging it into your calculator to make sure that what you've drawn makes sense. It'd be kind of silly not to. But I also won't give you any credit if all the stuff you solve for doesn't make sense with what your picture does. Alright, so that's approximately what it looks like. Let me go ahead and bring the camera over here so that you guys can see it a little better. So that's what I came up with. So notice I've got my little notes here that it's decreasing, it's concave up, that sort of stuff. I've got my points on there where it has to cross. So all that information allows us to graph a function without a calculator. So I'm guessing there is a multitude of questions So please let me know what you're thinking. Besides, is class over yet? So either the chat's moving really slow or nobody has any questions. So I'm going to go ahead and erase this guy. And I will do one more. And then I think there's a quiz for you guys you can do for this stuff. Alright, so we've got 2x squared over x squared minus 4. And we want to graph that without a calculator. So we've got to go through all these steps. Step 1 is what? Right, so let's find the domain. This is a rational function. So really the only restrictions here are in the denominator. So I need to set x squared minus 4 to 0. And so that's going to give me x equal 2 and negative 2. So my domain is minus infinity to negative 2, negative 2 to 2, 2 to infinity. A lot of people will leave out the negative 2 to 2 part. Okay. So clearly we already know that this thing has an asymptote, but we'll find that here in a second. Second part, look for intercepts. So set this thing to 0. You get x equals 0. So that's the origin again. And then if we plug in x equals 0, we get 0 again. So our only intercept is the origin. Third step is to determine any symmetry. So I need to find g of negative x. That's Plugging in negative x everywhere. And that is the same thing as the original, right? So if g is equal to g of negative x, that's even symmetry, which is symmetric about the y-axis. So a question here says, how do you know that there's already asymptotes? Well, it's a rational function, and I clearly cannot plug in 2 and negative 2 down here, because if I do, I get divided by 0, and that's a big no-no. So that means that the line x equal 2 and negative 2 are values that we cannot get to, therefore they're asymptotes. So 4, we've already solved for those. Right, x equal negative 2 and 2. To get the y asymptote, if there is one, we take the limit as x approaches infinity of 2x squared over x squared minus 4. Right now I would get infinity over infinity, which we're going to learn very soon how to treat that. But in this case, we can just divide through by the highest power of x everywhere. So this is now the limit as x approaches infinity. 2 over 1 minus 4 over x squared. Anything that's over x to a power, when x goes to infinity, heads towards 0. So this limit right here goes to 0, and we just get 2 over 1, or 2. So y equals 2, and x equal negative 2 and 2. Now we can do our derivative tests. So first derivative is low d high minus high times d low all over low squared. Simplifying, let's see, I'm going to take out a 4x. If I take out a 4x, I leave behind an x squared minus 4 and minus x squared. So those cancel, and you're left with a minus 16x over x squared minus 4 quantity squared. Then to find my critical numbers, I would set the numerator and the denominator to 0. Setting the numerator gives me x is 0. And setting the denominator, even though it's squared, right, if I set it to 0, it's just going to give me back 2 and negative 2 again. So again, good old number line. 0, 2, negative 2. So I'm going to plug in negative 3, negative 1, 1, and 3. plugging them into this. The denominator is really nice because no matter the number I plug in here, because the entire thing is squared, I don't care what the inside results in. Squaring it makes it positive. So the denominator is always positive. So I really just care about the numerator. It's already negative, so negative times a negative makes it positive. So positive, positive, and if I plug in positives, I'm going to get negative for both situations. I'll tell you right now, the biggest thing I see at this point is that students go, oh, well, this is all positive, so I'm just going to say increasing from minus infinity to 0. However, you can't do that because negative 2 is an asymptote. So you have to write it as increasing from minus infinity to minus 2 and from minus 2 to 0. And then it's decreasing from 0 to 2 and 2 to infinity. So we need that information. We now need to find the second derivative. First derivative's right here. So again, I need low times d high minus high times d low. So I bring the 2 down. I leave the x squared minus 4 alone to the first. And the derivative of x squared minus 4 is 2x. All divide by x squared minus 4 now to the 4th power. Same trick as we used last time. I've got an x squared minus 4, x squared minus 4, x squared minus 4. Get rid of this one. Get rid of one of those. Get rid of one of those. Then I've got a negative 16 in everything, so I'm going to factor it out. That leaves me with, in my first term, x squared minus 4. Then over here, I took out the negative 16. So I still have x, 2, and 2x. That's 4x squared, and it's minus. So now I've got x squared minus 4x squared. So that's minus 3x squared. And then everything's negative, and I have a negative out here, so I'm going to just make everything positive. Okay, so that's second derivative. We also have to find any points that make this 0 in the numerator or undefined, so 0 in the denominator. You'll find that the numerator is troublesome. If I set this to 0, move the 4 over, I get negative 4. And then I'm going to try to take a square root. That's complex numbers. So numerator doesn't help us. So I just need to solve the denominator equal to 0. And oh, by the way, we've done that multiple times now. That's going to give us negative 2 and 2 again. So once again, number line, negative 2, 2. So this time, the numerator appears to always be positive, because if I square a number, multiply by a positive number, add something to it, and multiply by another positive number, that's always positive. So I just care about what happens down here. So, negative 3 squared, that's bigger than 4. The cube then just keeps the sign. So this is positive. Plug 0 in, you get negative 4 cubed, still a negative number. And again, 3 in there, positive. So that tells us we are concave up from minus infinity to negative 3 and 2 to infinity, and down from negative 2 to 2. Also good information. I know that's a lot. I did it pretty quickly. I didn't write every single step. Anyone have any questions? Is that a negative 3 at the end? Right here, this is negative infinity to negative 3. It should be a negative 2, right? My mistake. There we go. So maybe let's do this. So we started up here. We found the domain. Right. Then step 2, we found our intercepts by setting x equals 0 and then setting y equals 0. We got just the origin for both. Third step, we found symmetry, so we found that it was even. The fourth step was to find asymptotes. So we had the negative 2 and 2 already. We had to take the limit, and we found y equal 2. Then we came over here, and step 5 was to take the first derivative. So we had to do quotient rule, solve that. We still got our negative 2 and 2, and then we got 0. Did our number line, found our increasing and decreasing. And then finally, see if I can get out of the way here. If I back up some. Nope, just always going to be in the way. Fantastic. So, took the second derivative, and then found our increasing, or our concave up and concave down. Make anybody sick just then? So now we've got to use all of this information to make the plot. Alright, so we know there's an asymptote at negative 2 and positive 2. So an asymptote here and an asymptote there. And then it says there's an asymptote at y equal 2. Okay. let's see. We've got to cross through the origin, right? So we know we touch here. We've got to be even, so whatever it looks like on one side of the axis, it's got to look like on the other. We've got to be increasing from negative infinity up to -2, so it's increasing in this region, and then it's increasing here, and then it's decreasing, decreasing. Then we are concave up. It is up here. And it's also up here. And it is down all through there, right? All right, so let's plot a basic function. So I'm going to plot something like x squared over x squared minus 1, for instance, just to get an idea of the shape. Okay, so according to that, it looks like we're going to be above this point, above that point, and then below this one. But if we have to go through 0, so it's decreasing here. See that? Write that in the right spot. No, I wrote these in the wrong spot. Darn. It's increasing here. That's good news, though. Decreasing there. Okay. So increasing here, decreasing there, always concave down means I have this kind of thing going on. Right, because I'm increasing up to that point, then I'm decreasing from then on. I can't touch these two lines, and I always have to be concave down, so opening down. Then in this region, I have to be increasing, so something like this, and I have to be concave up. It's going to look something like that. And then over here, I've got to decrease, but also be concave up. So we should look something like that. How do you guys feel about that one? Understand why I plotted the x squared over x squared minus 1 in my calculators to get a sense of the shape? Alright, so how did you know to put the horizontal dotted line there? Those were the asymptotes. So I knew that I couldn't touch those points. Right? We got that -2 and 2, and then y equal +2. So I'm not allowed to ever touch this line, or that line, or y equal 2. So that kind of gave me my framework to work around. So I'm going to give you guys a quiz on this today. So I would suggest asking any questions that you possibly can. Looks like there's one more here. Yep. Do you guys want to do that one? Or would you like me to do that one, I mean? Or do you want to try that one on your own? The function that I came up with, the original function was 2x squared over x squared minus 4. So I just took something as close to that with no multiplication, right? So I had a 2 before. I said, let's get rid of that. And then we had -4. I said, let's go with the simplest number. Let's make it -1. Obviously, you could plot the original function and then try to say, does what I have make sense? Do all these points tell me the right things? Alright, so if you guys want to do that on your own, what I would like to do is set up I'd personally like to set up a Zoom meeting for you all. So I can set that up and email it to you. That way I can see what you guys are doing. I want to be able to see what you're doing and see if it's something incorrect. So how about this? Let's call class a few minutes early. We'll go ahead and start L'Hopital's rule next time. I want you guys to spend the next couple minutes trying this problem. I will send you a link in your email, and that way I can see what you're all doing. So I'm going to stop this recording, and I will send that to you guys. You can still ask me questions on the chat if you like. And like I said, I'll send you the link.